Max, say hi to Ray. Say hi to Ray.
Hi, Ray.
Okay, so example 2 says find an equation for each ellipse and then graph it by hand. So pretty much anything said by hand, you're just going to have to approximate your radicals if you ever have one. Okay, how would you find the equation for 2a? What would you do first? Yeah, when in doubt, plot it out, y'all. Okay, so you have vertices are at 3, 0 and negative 3, 0. So vertex 1, vertex 2. Beautiful. Normally, when you guys are looking for an equation of an ellipse, you would need to identify your A value, your B value, and your C value. Is it possible for us to find A or no A right away? A was the distance from where to where?
Center to the vertices.
Yep, the center to one of the vertices, okay? So what is A? That's right. So that means I can do A squared right away. A squared would be 9. B squared is for us to find, but they gave us C right away. Guys, C was the distance from where to where?
Center to the bookstop.
Yep. Okay, so C squared would be 4. What's the Pythagorean theorem formula for us, for ellipses? Okay, C squared plus B squared equals A squared, or C squared in this case. I'm looking for B squared. So can I write B squared equals A squared minus C squared? So here we go. B squared equals A squared happens to be 9. C squared happens to be 4. So B squared will come out to be 5. That means rad 5 is going to be our B. Okay, so B squared is 5. What do we now need to graph our minor axis? Not the foci, minor, because I need to make an ellipse. The B, you're right. I'm going to go up rad 5 and go down rad 5 from the center. Rad 5 is in between 2 and 3, so anywhere in between 2 and 3 it should be fine. Okay, so this right here, it's your ellipse. Bless you. Looks like a potato. Now we need to write an equation. It said so. Is this horizontal or vertical? Horizontal. So I'm going to write x squared over something plus y squared over something equals to 1. How come I didn't write h and k? Yep, we love when the center is at 0, 0. So which one gets the a squared of 9? X or y? X, right? You're right, Quinn, because x is longer. So we get 9 here. And what goes on the y square? 4 or 5? 5 is b squared. Okay, so box that up. That's your equation. Okay, why don't you guys try b? Get a head start. I'll give you 2 minutes to get a head start on b. And then we'll come back together too. If you are stuck because you were absent yesterday, can you talk to your neighbors, your new neighbors? Or if you need some support, talk it out. Okay, just confirm.
find focus the same as like an a squared raised to the same a in the Pythagorean theorem equation? Center to the vertex. Oh wait. C. A is the center. It's just this. Okay.
Even though the question only gave you one foci, could you find the other one? Yep. Since the center, they're exactly 0, 0, okay, is to be symmetrical vertically. A, B, C, do we know at least 1, 2, all of them? What do we know? We know A equals 8, okay? Again, A will always be the distance from the center to the vertex or vertices, okay? Do we know B or C? C equals 4 units. C is the distance from the center to your foci or focus, one of the foci. All right. Now, we need to look for B. So Pythagorean theorem says B squared equals?
A squared minus C squared.
So we don't know what B squared is. By the way, what's 8 squared? 64, good. So 64 minus 4 squared would be 16. All right, guys, what's 64 minus 16? 48. So B squared equals 48. So B would be rad 48. Is that a nice number in there somewhere?
4 rad 3.
Oh, thank you. So 16 times 3, so 4 rad 3. Thank you so much. All right, so B is 4 rad 3. I mean, B squared, we just said it, it's 48. Yes, sir?
Why'd you put 2 foci up there if it was only give you 1 point?
Because you have 2 foci in the ellipse.
Okay. And they're symmetric?
Always symmetric about the center.
Okay.
The equal distance from the center.
So even if you're given 1 point, it's still...
Must be, So we have enough to plot our minor axis. Rad 48 is in between what? Well, I know rad 49 is 7, right? So less than 7? Is that okay? So between 6 and 7? Rad 36 will be 6. Rad 49 will be 7. So can I go from between 6 and 7? Okay, from the center. Here we go. I need some more tick marks then. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So in between 6 and 7 would be your minor. Okay. So now we need to write an equation for it. Is the center still at 0, 0? Yeah, so we're going to start with x squared over something plus y squared over something equals 1. X squared should be over what? B squared. And what's your B squared? 48, yep. Okay, because it's more vertically, right? And that means y squared should be over a squared, which happens to be 64. Box that up. Okay. Try C. Get a head start on C. Is this center 0, 0? No, it said center 1, 2. So definitely not 0, 0. So they gave you one focus at 1, 4, so that's your F1. Immediately, where should we plot, Chris M? Where should we plot F2, focus number 2?
1, -1.
1, -1. Do you guys agree with Chris? 1, -1? I think you meant to say this, right?
Oh yeah, sorry.
That's okay. I do the same thing sometimes.
I forgot what the center was at 1, 1.
Totally okay. Okay, so that's your center. So A, B, and C. Would that give us a C value at least? Yeah. Okay, so C value for this one, Michael, what do you think it is?
2.
Yep, so I'm gonna write C squared right away. C squared will be 4. It says this particular ellipse also has a point at 2, 2. Whoa. All right. What do you think that means?
Does that mean if it's symmetric, we plot it on the other side?
Yeah. Would you agree that's a minor distance right there? Minor distance is what? A, B, or C? B. So right away, we should know there's the other point, like what Tim said, on the other side. So that's your B value. B value has a unit of 1. So B squared will also be 1. So now I just need the major to finish sketching. So then, what's the quadratic formula again? Oh, I'm sorry, not quadratic formula. Pythagorean theorem formula again? B squared plus C squared equals A squared. Good. B squared is 1. C squared is 4. A squared is now going to be 5. Okay, so rad 5 would be A. So A equals 5. Rad 5 is? Between 2 and 3. Yep, so go up a little bit more than 2 from the center, not from the origin. Okay, so go up 2 and some change. I need to add one more tick mark up here. A little bit above 2 from the center, and a little bit below 2 from the center. And you have this skinny little guy. Yeah, my ellipses are quite ugly. All right, equation. Should we use H and K now?
Yes.
Yes, it's no longer at the origin. So I'm going to write x minus h quantity squared over something plus y minus k quantity squared over something equals 1. Is this more vertically or more horizontal?
Horizontal.
More vertical. So would you agree that a squared should go under the y? And that means this should go the b squared, the shorter goes under the x's, okay? Let's fill it all in, okay? All right. So Sophia, whenever you're ready, give me your final equation of this ellipse.
X minus 2 squared all over 1 plus y minus 1 squared over 5 equals 1.
Good. Perfect. Yes, no, maybe?
I disagree. It's x minus 1 squared plus 1.
Oh, did she switch her H and K? 1 and 2. Okay, there you go. Good job. Good eye. All right, let's go backwards. Now that I give you an ellipse, can you give me the equation? You probably need to find what if you're looking for the equation?
Center.
Center. What else?
Vertices.
A, yep.
Okay.
And B, right? And maybe sometimes C. Sometimes you have to list out the C to find your B or your A. I think this one you can count, didn't you? Where is the center? I'm gonna have to figure that out later.
Okay.
So center is at -2, +1. Hannah, were you able to find an A value at all? Okay. How long is that A value? 3? Okay, A would be 3. Can we also count to find B? Mm-hmm. So that means A squared would be 9. Okay. Grace, were you able to locate B, distance?
It's B, that should be 2 units.
Mm-hmm. Very good. So B squared would be 4. Because it only wants us to write an equation, is that enough information for us to write an equation? Yeah, for sure. Okay. Vertical or horizontally? Vertical. So it would be x minus h quantity square over something plus y minus k quantity square over something equals to 1. Because it's vertical, a squared will go under the y and b squared will go under the x. Okay? Alex, whenever you're ready, tell us your final answer. Do you want to move closer, Alex?
No, I'm
Okay. Okay, tell me what's right.
Okay, so it's x minus x plus 2 squared over 4 plus y minus 1 squared over 9 equals 1.
Good, beautiful, nice job. Last example of today, guys. So example 4, can you help me read? Emily, can you help me read example 4?
The mean distance of Mars to the Sun is 142 million miles. The perihelion of Mars is 128.5 million miles. What is the perihelion? Write an equation for the orbit of Mars about the Sun.
So yesterday you were asked to define the definition of the mean distance of a planet from the Sun. You were asked to define the perihelion. What was the definition of perihelion? Furthest from the Sun, yeah? Or closest, which one? Because I just heard closest. Okay, perihelion is the closest from the Sun. Aphelion is furthest. You only have 2, right? So the Sun, let's just pretend the Sun is somewhere here. Then you have a planet orbiting around the Sun, as you know. In this case, it wants to talk about Mars. Okay. It can be anywhere. So there's a distance. This is the closest to the Sun if it happened to be here. It may not be, but that may be the distance closest to the Sun. So if it's closest to the Sun, we're going to label it perihelion. If it's somewhere over here on the left side, well, that's furthest from the Sun. Would you guys agree with that too? Okay, so that's going to be aphelion. Okay, so another term that I gave you is the mean distance, okay, of a planet, in this case Mars. So the mean distance is an average. So the average of these two happens to be what? 142 million, right? So because it says the average of these two, what that means if I take perihelion and perihelion and aphelion and add and divide by 2, I should have a distance of 142 million miles. So pretty much the mean distance is the distance for what variable? A. So A is 142 million miles. Okay. They give you 128.5 million miles for perihelion. So this guy here, the closest dude over here, is 128.5 million miles. Now, believe it or not, the sun is one of the foci. Okay. So where the sun is the foci. So, is it possible for us to find C? C would be, what do we do to find C? Okay, 120.5 is not C, it's the other side of C. C is from the center to the sun.
So 142 minus 1.
That's right, 142 minus 128.5 millions. Let me know what that decimal is. So what's that one? Some big millions. Well, not that big since we have 142 millions. 13.5 million is 0.5. Okay. Then it says write an equation, so that means I need a b value. Okay. How do we find b value again? B squared equals a squared, take away c squared. So b squared equals a squared is 142 million square, take away 13.5 million square. Can someone punch that in and tell me what the answer is in millions? 19,981.75 millions. Okay. That's b squared. I'm not going to leave it as b squared because your equation would be over b squared anyway. Okay. So, as you can see, we are going to assume the centers is 0, 0, because that would be easiest. So it would be x squared all over, sorry Max, plus y squared all over equals 1. So we are going to put a square with the x square, so that's going to be 142 square, 142 million square. Yes or no? Okay. Then y square will get that whole thing square. Well, actually, that's already square, huh? Because we never took the square root. Okay. So that's already square because we never took the square root. Can you guys agree with that statement? Okay. So I'm just going to write that whole thing over. So 19981.75 millions. Okay. And guess what? That is the equation. So we can find the location of Mars orbiting around the sun. And that concludes our notes for today. Go ahead and start your homework if you choose to, and I will come around and stand.